Okay, for this video, I'm going to go through about 8 examples of factorising, ranging from going into one bracket, going into two brackets, and then looking at some of the more complicated versions of the two brackets factorising. So, first example, I suppose. So I want to factorise 15g plus 27g squared. So not that complicated to begin with, although they can be easier still. So what you'll notice is there's only two different terms going on here. So it's not quite a quadratic with a number. So this is an example of where it's just going to go into one bracket. Okay, so what I need to look for is common terms in both of these terms that can be pulled outside the bracket, and then I divide each term by that and then put what the remainder is inside the bracket. Okay, so if we're going to have two brackets, we're going to have a plus in between. So what's common to both 15 and 27? So I want a common factor, the highest common factor, mind you, always has to be the highest one. So 3 goes into 15 and 27. The next factor would be 5, but 5 doesn't go into 27. And the next one would be 15, but that doesn't go into 27 either. So we're going to have a 3 outside the bracket. There is a g, at least one g in both terms. So we can pull that g outside the bracket as well. So times 3g by 5 to get 15g, and times 3 by 9 to get 27. And don't forget I need to times the g by another g to get my g squared. Some of the times you won't necessarily get you won't necessarily get a g outside or a variable outside the bracket. Okay, so let's have a look at a slightly harder version of a one bracket factorization. 8y squared x squared minus 16yx cubed. Okay, so start by looking at the numbers. What's common to both 8 and 16? Well, that will be 8, so 8's going to come outside my bracket. What's common to y squared and y? Well, that will just be y. What's common to both x squared and x cubed? Well, that will be x squared. So then inside my brackets, I need to multiply this first term by an extra y to get this first term. So we're going to have y take away. Right, I need to multiply 8 by 2 to get 16. Y gets to y, that's fine. And I need to multiply x squared by x to get x cubed. Okay, so it's all about taking out common factors. So this is two examples of single brackets. Let's start looking at the more complicated double brackets. So I want to factorize g squared plus 11g minus 42. Okay, so what I'm looking for is to put it into two brackets. There's no number in front of the g squared, so it's a nice straightforward one to begin with. To get g squared, I'm going to have to multiply g by itself, so therefore there must be a g in both brackets. Then I need to look at the numbers that go in the bracket. So these two numbers must multiply to make minus 42. So let's have a look at the numbers that multiply to make minus 42. One's going to have to be a positive and one's going to have to be a negative. So we got 1 and 42, 2 and 21, 3 and 14, 6 and 7. That is a 7. Okay. So if one's a negative and one's a positive, they've also got to add up to make this plus 11. So therefore, if they're adding, if a negative and a positive is adding to make a plus 11, that means the positive must be bigger. Okay. So looking at these numbers, which of these will add to make plus 11 if the positive one is the bigger one? So if I've got a plus 7, take away 6, that gets me 1. Plus 14, take away 3, that gets me 11. So those have got to be the numbers. So it's going to be a plus 14 and a minus 3. So pop them in either way around, doesn't matter. And there's your factorization. Right, so for any term where there's no number in front of the g squared, that's the process you should be making. Sometimes these signs are different. So if this was a plus 42, then the two numbers could either be both positive or both negative, because they will multiply to make a positive number. You need to be really careful with the signs, okay? And it's always important to look at the sign in front of the linear term, the one term on its own, okay? Because that will tell you what's going on with the numbers as well. Right, let's have a look at a slightly different example, this time where there is a number in front of your variable. So I've used the variable x this time. So there is a little bit more work to be done here, but not a lot. Okay, there's just a few variations. The more you practice this, the better you'll get, okay? And you will have to practice this to get really good at it. So instead of just taking the -5 and looking for numbers that multiply to make that and add together to make 17, it doesn't quite work like that. What you have to do is you have to take the 12 and times it by -5. Then you look at the factors that multiply to make -60, okay? And we compare those to make -17 when we add them together. So two numbers that multiply together to make 60, 1 and 60, 2 and 30, 3 and 10, 5 and 12, 6 and, sorry, not 3 and 10, 3 and 20, 6 and 10, 7, 8, 9, 10, no, there's no more. Right, one's got to be negative, one's got to be positive to make a -60. The number in front of the x on its own is a -17, so therefore the biggest number must be a negative. So that's got to be a minus, 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 okay, in front of all the bigger numbers. So 60 plus -60 plus 1 is -59, not -17. -30 plus 2 is -28. -20 plus 3 is -17. Therefore, this must be your pair. Okay. So what we do is we take the 12, the number that's in front of the x. That's one of the numbers in my bracket. And then I take the other number as one of the other numbers as well. So that was a +3. In the second bracket, I take the 12, the number that's in front of the x squared term, and I use x. And then I use the other number, which was -20. Feel free to pause this at any time if you need to think about it or go back over it. Okay. Now, it looks like I've got the right factorization. My only problem now is when I'm going to multiply these things up, I'm not going to get -5. 3 times -20 gets me -60. Well, that's an extra factor of 12. 12 times 12 gets me 140. That's an extra factor of 12. And then if you worked out what the x's would get you, you'd get 12 lots of 17. So what you need to do is divide through by 12. Now, the only problem we've got now is 12 doesn't go into this bracket fully, and 12 doesn't go into this bracket fully. So I'm going to break my 12 up into two numbers that will go, one will go into one bracket and one will go into another. So 12 can be broken up into 3 times 4. 3 can be dividing the first bracket and the 4 can be dividing the second bracket. That is a 3. Okay, and that's how we do this. So divide 12x by 3 and I get 4x. Divide 3 by 3 and I get 1. Divide 12x by 4 and I get 3x. Divide -20 by 4 and I get -5. And that's it. That's your factorising. Done for that question. Now, if you follow this method for every single quadratic you do, you will get the right answer. If there's no number in front of an x, if there's no x term, that means the number must be 0. Okay? But there are some little tricks that we can do to help us solve some of those questions. Especially when you have a normal quadratic to look like this, use this method. Okay, much easier when you don't have a number in front of the squared term, like in question 3. So let's go through some that are slightly different. And the first one is I want to factorize x squared minus 64. Now there's no x term, but this one's special because x squared is clearly a squared term. Yeah. 64 is a square number. So this is what we call the difference of two squares. And there's a nice little trick for you to be able to do this. And it is literally take the square root of both of them and put them in two brackets. Square root of x squared is x. Square root of 64 is 8. Square root of x squared is x. Square root of 64 is 8. And then to get the 0 term on the x, that means these two signs must be the opposite of each other. So we just put a plus and a minus inside your brackets, and that's it. It's called the difference of two squares. Really quick and simple one to do. So you take the square roots, you put them in the brackets, one has a plus, one has a minus. Done. Okay, let's have another example similar to that. What if I had 64 minus x squared? Okay, it's a quadratic still. If I wanted to go through the process of doing the x squared stuff, looking for the numbers that multiply to make 64, but add together to make 0, then I would still get 8 times 8. One is a plus, one is a minus. But this is the difference of two squares again. This time, though, you're going to swap the 8 and the x around. So in one bracket, you're going to have an 8. In the other bracket, you're going to have an x. It's no problem doing it this way. The other bracket 8, the other bracket x, and you're going to have a plus and a minus in between. If you were to expand that out, you would get 64 take away x squared, depending on how you wrote it, of course. Okay, 2 more examples to go, and then you can crack on and have a go at some questions yourself, all right? Question 6. Right, this one they might ask you to factorize fully. Okay, so what have we got? We've got 12x squared minus 27. Now it doesn't look so clear cut that it's any particular kind of special kind of quadratic at the moment, but you don't have any x term, so you might be mistaken in thinking, oh, it looks like a difference of two squares, but you're not. Okay, the only problem is these two numbers are not squared numbers. So what we do, first of all, is take out a factor that we know goes into both of them. Right, number that goes into 12 and goes into 27 is 3. And we're left with 4x squared minus 9. Right, 4 is a square number. X squared is a square number. And 9 is a square number. So yes, we have a difference of two squares. Don't forget that the 3 is out the front still. Right, the square root of 4 is 2. The square root of x is x. So 2x times 2x will get you 4x squared. The square root of 9 is 3. And let's do the other bracket. We're going to have 2x and 3 again. And because it's a difference of two squares, I just need to pop in my plus and my minus. And that's it factorized fully. I am going to show you one more. Okay. How many have I done so far? I'm not sure. 4. Oh, right. Yes. No, I've done 5, 6, 7. So I'm going to do the 8th one now. Last one. Okay, this one's slightly different, and they're going to ask you to factorize fully again. Okay, so factorize fully. 9x cubed minus 48x. Now it's not a quadratic, because a quadratic has an x squared term as its highest power. Okay, this one is a cubed term. But I can because there's an x in this last term, I can also turn this into partly quadratic and partly linear. If I were to factor out an x, then I would be left with an x squared. So let's do that first. I've got x lots of 9x squared minus 48. There's not a lot I can do with that now, apart from factor out a 3. I could factor out a 3 as well. So there we go. So factor out a 3 as well. So I've got 3x on the outside, and I've got 3x squared minus 16 in the bracket. Now that's not a difference of 2 squares either, because this is not a squared term. So sometimes you can only go so far. But if this 3 were a squared number as well, you would be able to do then this difference of 2 squares. All right. So don't be afraid that if you've got an x in each term to factor out an x and then try and do some factorising afterwards. Right, that's it for today. So it's all about factorising. And then hopefully next week we can start using some of it maybe to do certain stuff. All right. Have a great day and enjoy your weekend when you get there.